It's Jeff Mucci with RCR Wireless News, and today we're talking Information Centric Networks with Dirk Trossen, who is Principal Engineer in the London office for InterDigital. Dirk, thanks for joining us today.
Thanks, Jeff, for having me.
So my first big question is, what is an Information Centric Network? Let's start at a high level, and then we'll peel the onion back from there.
Yeah, an Information Centric Network is a network where the information itself is identified rather than an end host as it is in the IP network nowadays. Instead of sending a packet from an IP address A to an IP address B, you're publishing information with a name, with a label that is attached to it, and you're retrieving information. It doesn't matter where you're retrieving it from, because the endpoint address doesn't matter. It only matters what you're actually retrieving. So therefore, information at the center rather than the endpoints themselves.
Well, I'm going to pull up a slide here that talks about the problem that carriers face today and the future, maybe the current approach to solving it. But let me pull this slide up quickly. So Dirk, talk about the problem we have today and how it's being solved.
Yes, so what you can see on the left-hand side of the slide is a typical kind of large-scale content distribution scenario with standard content providers like the Amazons, the Netflix, etc., delivering content into an operator network and the operator trying to disseminate content within the network to many users at the bottom of the picture. The problem in today's network is a proliferation of HTTP unicast viewing, personalized viewing. People want to, watch their Netflix video whenever they want. They pause, they go back. It's not synchronized. It's not a cable TV type of experience where you're scheduled at 7:30 in order to watch the movie. It's an individualized viewing. Now the viewing is delivered through HTTP unicast. Content is pulled from the content servers and individually delivered to the users at the bottom of the picture. The problem with that which is visualized with the graph on the right-hand side, is that the number of user connections, you have a linear increase of bandwidth cost. Because every user incurs an individual linear increase of cost because of the video sent individually to that user, even though it might be delivered to a number of users as well. The current approaches that are used to tackle that problem are obviously CDNs, content delivery networks, that place popular content closer and deeper in the network, and therefore bring the actual content closer to the end user. The problem with CDNs is they are overly complex, and they result in a number of inefficiencies because of the indirections that are involved. Even though you are, from a perception point of view, going to Netflix, you're redirected to a CDN, and all of that engineering in order to make that work is overly complex. The second approach to cope with the increasing cost is simply over-provisioning. So you're pumping more and more resources into the network, you make the pipes bigger in order to foster the personalized viewing and in order to grow to the right-hand side of that graph that you're showing. Both of these issues are, of course, unsustainable for future networks, particularly for 5G. You have more and more users, more and more personalized viewing, higher bandwidth requirements with 4K, and higher resolution videos, and therefore, that type of over provisioning and indirections can't continue really.
Well, I'm gonna move up the stack, if you will, and let's take a step back and talk about where this new network fits in the bigger picture of 5G.
Yeah, so what you can see in the picture here is our view of a future 5G network. At the top with the app economy that's been driven, in particular in the mobile world, with various scenarios, based on certain APIs, on what you can perceive as a network operation system, with discovery functions, security function, and analytics functions, and orchestration, and again built through a common set of APIs onto what we call a programmable core network, facilitated through techniques like NFV and SDN. And the efforts that we are having here in this space particularly is in the area of the core IP transport network, which in the future is not going to change. It's going to be IP-based. The common set of abstractions are IP, HTTP, RTP, the type of well-known protocols. We also have efforts in the integrated front-haul backhaul space, which is essentially about radio access networks, integrated into a common substrate that can accommodate a number of front-haul technologies, different wireless access techniques that are being used, and all of that again, surrounded by 5G devices, things, sensors, etc. So our efforts largely in the core network, core IP part, and at the higher layer, very much involving orchestrations. How do you make that work over a number of network substrates, over a number of operators which require the orchestration function?
Got it. Well, I'm going to jump back down to this slide. So, in short, mobile video unicast is really driving a change in the network. And I've heard you say that this network in the future is going to look like IP, smell like IP, but it's different. What exactly do you mean by that?
Well, what we're trying to do is the first part, it looks like IP, it smells like IP. We preserve the actual abstractions. It's still an IP network. It looks like an IP network from those that actually matter the most, and that is end users because of their end user devices. Changing end user devices, changing protocol stacks on end user devices is fairly complex. It takes time. Changing applications is even worse. We don't want to change the applications. Very difficult to tell an application programmer, we have this really new fancy system and it's going to work better if you use our API. It's not going to work. There are a set of well-accepted APIs we don't really want to change. So that's it looks like IP. We also preserve most of the relationships. There's still a relationship between content providers, network operators, and consumers. But what works differently, that's the works different, is the inner workings of the blue bit you're seeing on the left-hand side, the actual network. And we do change how the network operates while still preserving the actual abstraction, but working very, very differently than an IP routed network.
Okay. Well, let's, before we move on to the project that InterDigital is involved with in Europe, what I'd like to do is maybe talk a bit about the benefits to the carriers and the web-centric IoT or OTT providers like you had at the top level there. And the real question is, what's going to be the catalyst that's going to force carriers and OTT and cable companies into this new type of network?
Well, let's go for the second question first, and that's what's really the drive and the change that really pushes us in that direction, and that's clearly increasing and demanding 5G KPIs. So an increase or decrease of service level latency for some of the future demanding services is a key driver. In a lot of these scenarios that you see in 5G being mentioned, going end to end is unsustainable. It takes you longer to get to a remote server, and the best solution from a network perspective is bring the server closer. So this whole idea of establishing surrogate servers nearby the end users, and in our vision, servers being at a minimum one hop away only from a user, that's what's going to bring your service level latency down to very interactive, augmented reality and virtual reality scenarios. The second one is obviously cost. As I mentioned before, you move from SD to HD to 4K, and proper, immersive experiences. Bandwidth will explode even more, and sending unnecessary, requests twice, or like in the Netflix scenario, tens or hundreds of times to people who want to have the perception of individual viewing, but also with today's technology, receive individual videos of the same type. That's just unsustainable, and it pushes the cost up, and therefore it makes these type of delivery systems unsustainable. And that's the big change that really drives to solution that we are developing. The benefits clearly for operators is the reduced costs. So really keeping up with the curve of increased bandwidth need and keeping cost at a sustainable level for both content providers and content users to provide services and enjoy services. For content providers, any way to disseminate content cheaper is a good thing. So there seems to be a very, very straightforward win for OTT content providers. Also, the ability to reach end users easier by providing surrogates closer to end users is a good thing for a content provider because it increases quality of experience and therefore makes the service more attractive.
So at the top layer, we got the web-centric content providers. They're going to fundamentally reduce their costs because they're going to get their content closer to the customer. The customer is going to enjoy a better experience, and then the carrier will fundamentally reduce their kind of this exponential growth of OpEx associated with network planning. And I do want to, you mentioned the over-provisioning of resources drives unsustainable spiraling cost. Last month while in London, I moderated a panel at the Data Center Dynamics event, and we had several network providers on the panel, as well as equipment providers, and the topic of the panel was network capacity planning. And we talked about what tools carriers are using, how they're planning for this exponential growth, and at the end of the day, one of the folks on the panel said that they're provisioning 50% more capacity in their network than they think they're going to need, because there's fundamentally no way to predict where and when they're going to need capacity. And all they're doing is reacting to these demands from their customers, which in turn are carriers or the web-centrics who are modifying where they're locating their content and trying to get one hop from their customer. And just on this slide, the bottom layer, just to be clear, when you say CPE, that could be a desktop, it could be a laptop, or it could be a mobile phone or tablet.
Absolutely.
Okay. Well, let's jump down to and maybe talk a little bit about your project that's part of the Horizon 2020 program. And I think you've got 2 projects in place. Let's summarize what the projects are, Point and Riff, and what your end game is with those projects.
So what we're trying to do with both projects, they're heavily intertwined, is to obviously tackle the red curve on the right-hand side. So, and we have 2 propositions to tackle that curve. The first one is to introduce true multicast in a world of individual unicasts. As I mentioned before, personalized viewing creates a unicast experience. It is implemented via unicast. And even in cases, in a large-scale content providers, these cases are very common, where people do watch the same video. The video is delivered individually to the end users. With the technique that we are putting in, and on the left-hand side, you saw the appearance of the green bit in the picture, and what we call the ICN intelligence on top of the SDN controller, allows us to reintroduce multicast and therefore increase the network utilization, because we are able to replicate more bits in the network through multicast than you're actually pumping into the network, and that pushes your red curve down to the green curve that you can see on the right-hand side. And we achieve this through a flexible routing, which is implemented in this green ICN intelligence box at runtime, and you can push anywhere in a small little data center in an operator network. It increases resilience, and therefore it increases latency by being able to reroute and react to path changes and to network failures and server failures quicker. We are also able to reduce latency by placing servers closer to end users, which leads us then to the second benefit that we're building up.
Okay.
So the second benefit is shown on this slide. So in addition to the implicit multicast that I mentioned before, the next logical step is to move web servers dynamically around in the network and move them closer to end users. In this case, it could be one of the data center services on the top of the pictures that moves to the bottom of the pictures, and therefore, in this case, literally one hop away. And it creates, in addition to this, not only you reduce obviously the service level latency, you also reduce the actual bandwidth being sent over the network, because the bit from the top to the switch at the bottom is not used anymore, and therefore you have an increased network utilization. But it also creates new service possibilities for operators by providing these type of dynamic web servers through NFV platforms and providing what we call a surrogate service that establishes a uniform computing resource across the network that web server providers like Netflix, like Amazon can utilize in the network very close to the end users, where the real estate is extremely difficult to get by. Placing computing resources in a base station is still a prerequisite for an operator. You won't see an Amazon cloud anywhere in the near future near a base station. That's not going to happen. And therefore, operators can utilize that in-networking computing facility, expose that to web server providers like Amazon, like Netflix, which in turn allows these providers to put the resources closer to the end users. And that, in the end, is what gets us to the 5G KPIs. It gets us to the service level latency. It gets us to the 1,000 capacity increase. Because for the end user, it does look like the capacity has increased, but the trick here is by localizing communication, this capacity has perceptually increased.
So when you talk about dynamic web servers, are you talking about basically virtual space in a co-location center that's physically in a metro area and most likely a co-located facility of some sort?
Yes, so in-networking computing is already built into various switch products and obviously can be inserted through in racks in operator facilities. NFV as a technology allows you to expose these type of computing resources, and we can utilize them to establish these web servers dynamically. We can move web servers around from one location at, for instance, a BRAS in a metro network into a base station in a mobile network. And the flexible routing solution I presented in the previous slide allows us to redirect or to flexibly change the route from the end user to the web server very dynamically. Because it doesn't use any DNS indirection or any inefficiencies at the very higher layer, the change is not only implemented very fast, but is also implemented efficiently, because in effect, the end user will directly talk to the web server on the shortest path, and therefore very efficiently.
Can you talk a little bit about the difference between this routed network versus switch traffic, and in terms of how fast the user feels the experience or downloading or watching the video?
Fast in terms of changes, or in terms of speed? The speed is we are building the solution straight on top of SDN, which means it's a high performance solution. The routing only happens at the beginning, which means the communication between the CP and the web server is established. That's where the routing happens. After you start pulling the video down, it is a purely switched network, meaning it goes straight over the SDN switch to the web server and comes down. There's an element of fluidity, obviously, when the web server moves. One of the showcases we're going to demonstrate next year is a web server where a number of users pull video from a common server, and therefore at a certain quality that the network can sustain, and that web server is then partially relocated in part of the network, so that users closer to the relocated web server redirect the traffic to that web server, while the other users continue to watch from the first server. In that case, the change from the original server to the surrogate server is going to happen in a sub-second speed, so it's relatively quick when you can see the increase in quality that's happening for the set of users that are closer to the second server. That's what we intend to demonstrate in that case. So that's the second part of fluidity. How quickly can you adapt to changes in the network that in this case, the operator decided to place a server closer to one set of users. And that is fairly quick.
In order for this to be deployed in full, we talked a lot about server and storage. We've also, as an industry, been talking a lot about Whitebox servers. And while at the Data Center Dynamics event, Facebook was there with kind of their next generation of Whitebox server. HP Enterprise was there with custom-made servers. Can you talk about Whitebox servers in the context of this diagram?
Anything you can see, even though they're actually shown in black, essentially standard COTS equipment, right?
Yeah.
And therefore, it's not necessarily a specialized rack that we are building our solution on. You can literally, in most of our demos, we will literally place COD software right next to an SDN switch. That's going to be a standard desktop. As long as you can run an NFV, an open daylight type of platform, OpenStack platform on top of it, it doesn't really quite matter what's the underlying hardware. It's exposed as a unifying computing platform. That's the proposition really from an operator perspective. Yes, I can utilize the specialized boxes, but I can as much utilize very generic, COTS hardware. And that's integrated. And obviously, from a web server perspective, it matters even less as long as you have the right virtualization virtual box. You just run the web server on top of that.
What are some of the challenges that carriers are going to face and web-centric service providers are going to face deploying this type of network?
There's a lot, to be done to obviously make this work at scale. There's a lot of engineering that still needs to be done, but in many ways, the enabling technologies are all there. SDN is increasingly being deployed. Operators are looking into the pros and cons. The type of integration we have with SDN is very appealing because it's relatively simple and it requires very little management effort, but obviously you still have to tackle the management challenges. The software has to be tested, but one of the nice things about SDN and one of the opportunities of SDN is the software-based approach. It is, from our perspective, it's nothing else than a licensed software you install on your SDN infrastructure, and you run it like any other routing software you would run. We have a certain list of propositions that other routing software doesn't have, but in the end, it is nothing else really. It is a program that's running, on top of a set of SDN controllers, and that's really the beauty of what SDN has really enabled. I think most of the challenges probably lie in, operators fully adopting that type of model, and it certainly poses challenges to the way testing and certification is done. However, on the other hand, we work also with partners on utilizing the ability to have a separation between software and hardware to change the way testing is done. If all your testing is essentially the software, you can use ICT tools, IT tools rather than telecommunication tools to test a network before it's even rolled out, because all your testing is software. And we showcase that as a part in next year as well, where we build up a network that is partially a real network. But large parts of the network is an emulated network that resides entirely in the cloud. It uses the same software that runs in the actual network, and the behavior is obviously as if the network would be fully real. That's one of the beauties really, but the challenge is to really get that type of mindset into the telecommunications world, which is a much more IT type of ICT type of mindset. If there's any challenge, that's probably the biggest one really.
Okay, and so talk about when you say IT tools or ICT testing versus telco testing. Can you give me an example of what an IT tool might be to test this type of environment?
Well, one of the tools that we've used in the development of this software is our emulation tools that allow us to build small little networks entirely in a number of virtual machines, and we boot them up in the cloud. It is a hundreds of nodes network that we can spin up in the cloud. There's no real infrastructure involved, but you can run scalability tests, performance tests that are the same as if you would run them in a real network. These are tools that haven't really been used in the telecommunications world so far, and that allows us to test features and scalability aspects of the software without putting it on real boxes and real SDN switches.
Got it. Well, this last slide I've got up talks about the project you're doing, the Rifen project. What is InterDigital's role in this project, and what are some of the other players' role in the project?
So the projects are usually constructed. These are two projects in total. We have 15 partners. I think it's 7 and 8 is the division between the projects. And the projects are, by the objective of the European Commission as the funding agency, usually constructed along a value chain. So you can see that on the left-hand side. So we play the platform provider role. We have vendors from the satellite space as well as the traditional telecommunications space. We have operators as well as SMEs, and obviously a strong role for academia as well. So this type of research value chain is the one that's very representative, and we have a very strong role with involvement of operators, because both projects have trial commitments. Primetel is our operator in Cyprus, is one of our trial sites. Goofy.net, an operator in Spain, where we trial throughout 2016 and 2017. Obviously, working with vendors is very important as well. So it's the construction of that type of value chain-driven consortium that usually plays a role. InterDigital, we are the technical manager of one of the projects, and we are the architectural lead of the second project. So it's a quite central role where you can drive the ideas and the views and the vision we're having directly into the project, in addition to the technology, obviously, that we're developing in these projects.
Are carriers going to wait for standards to start implementing these virtual multicast and virtual dynamic server solutions?
So in parallel to developing the solutions, we're also looking at standardization efforts, and we're planning to go with some of those to the IETF next year as one of the protocol enabling bodies. We also have started discussion in 3GPP, in particular with respect to 5G. There's a lot at the moment happening around the caching story, which is where we bring a very different angle into the discussion, because we're moving on from pure content caching into service surrogating, and service surrogation is obviously goes further than caching because it includes the computation as well and not just the static content. So we're trying to bring these type of visions into the standard bodies as well. And there are obviously different speeds in each of these bodies, and we have to accommodate those. But we start relatively early, which means in 2016 to push some of those things into standards.
Okay. Well, Dirk, thank you so much for your time today. I appreciate the overview and look forward to following up with you on some of the other H2020 initiatives that InterDigital is involved in. So have a great weekend. Thank you.
Yeah, thank you very much. Thanks. Bye-bye.